Good day to everyone. Welcome to another video. So I hope you had a great day. So for this video, what we will be exploring is that we will try to derive yung equation natin for your sterile parallax. Okay? So I will keep it short and simple. So I hope you leave a like later on after this video. Okay, so let's start. So before we go on to the derivation itself, just a quick background muna about sterile parallax. So when we say sterile parallax, okay, mainly we are talking about the equation. It is an equation that relates the observed angular shift of a star, sometimes you call it yung parallax shift, okay, due to the Earth's motion around the Sun to the distance of that star. So if we try to observe a certain star by January, and then try to observe it again by June, so that's like 6 months, okay, apparently yung position of the Earth moves around the Sun, so we will observe a small shift in the position of a star. Okay? So we call that parallax angle. So later on, magiging useful yung parallax angle natin. Okay? Sige. So I have here a drawn diagram earlier. So we have the Sun, we have the Earth, and then we have the star. So what are the things that we already know about this figure? Okay, we all know that the distance between Sun and the Earth is approximately equal to one astronomical unit. Okay, yan yung distance of the Earth from the Sun. And there is a distance also of the star, okay, which is represented, we can represent it by letter D, okay, as well as the distance of the star to the Earth. Okay, so, or maybe we could just say that this is X. Okay. Now, ano yung observation ninyo dito? You can see that this figure forms a right triangle. Tama? It forms a right triangle. So we can draw the figure as something like this. Okay? So in a right triangle, you have the angle, okay, which is represented by theta. Here, okay, we have that angle also. Okay? In terms of astrophysics, itong angle na to, tinutukoy dyan yung parallax angle that the star forms due to its shifting in position in different time frames. Okay? Yan yung shifting of the position, yan yung angle that results from the shifting of the position of the star. Okay? So, aside from that, the longest part in a triangle is what we call your hypotenuse. And then, we also have the adjacent, okay, adjacent of the angle, and then you also have the opposite. Now, turns out that we need to find the distance ng star, okay, to us, and we can use simple mathematics for this to happen para makuha natin yung distance. So we can use yung trigonometric identity, so katawa, okay, for us to solve this. Okay, so we can use yung TOA. So it says there that tangent, we can just, anyways, tangent, okay, is equal to the opposite over the adjacent. So dito sa diagram natin, ang opposite natin dito will be the one astronomical unit. Okay, so theta. So theta represents yung stellar parallax. So I'll just write it here. Stellar parallax. Oh, we only have one R. Sorry. Parallax. Okay. Divided by the adjacent, which is represented by the distance, by the letter D. And that is now your stellar parallax equation. Okay? So, it is very, very clever for scientists that they were able to do this in early times. Okay? Because as you can see, okay, we already know yung distance of the Earth to the Sun. That's one astronomical unit. That's like constant na siya. We also can determine yung parallax angle natin by observing a certain star at different time frames. Kasi, okay, let's say this is you, and then this is the star. Oh, sorry. This is the star. Okay, I think star. Oh, should be, no. This is the Earth. Okay, let's use green. This is the Earth. Okay, and then this is the star that you are trying to observe. Okay, so let's say you observe this one by January, and then this is the sun. Okay. So after 6 months, what will happen is that the Earth will rotate around the sun, okay, in opposite direction. Opposite position. Okay, so nandito siya ngayon. And then if you try to again look at the star, okay, you can notice that there's a shift in its position. And yung shifting of the position can be represented by the angle that it forms. Yun yung theta. Yun yung stellar parallax natin. Okay? So for us to be able to determine the distance of the star to the Earth, okay, that will just be equal, okay, to the 1 AU divided by the theta. Remember, this stellar parallax is in the form of arc seconds. Kasi usually hindi naman ganun ka-major shift yung shifting of the position ng stars natin. That's why we are just using arc seconds. And stellar parallax can only be used to stars that are near to the Earth. Okay, hindi siya pwedeng gamitin para sa mga stars na sobrang layo because, again, remember, the farther an object is, the lower its stellar parallax angle that it can form. Okay, so kumbaga na lang siya para sa mga near stars dito sa Earth. Okay, so now you can use this equation to solve for the distance.